What if I told you the Earth itself was vibrating for 9 days straight in 2023 and no one saw it coming? This isn't a sci-fi plot. It's a real seismic mystery that left scientists scratching their heads until recently. Let's unpack how a single landslide in Greenland triggered a planetary-scale event, and why this story might just change how we think about climate change's hidden dangers. Back in September 2023, seismic monitoring stations from the Arctic to Antarctica picked up an eerie signal. Unlike the chaotic rumble of typical earthquakes, this was a single, unchanging tone, a monotonous hum that persisted for 9 days straight. Stephen Hicks, a computational seismologist at UCL, and Christian Svenevig, a researcher from Denmark and Greenland, described it as the most puzzling signal we've ever recorded. The wave's unique frequency and global reach defied all prior seismic records, sparking a race to decode its origin. Here's where it gets truly intriguing. The team initially labeled the phenomenon a USO, an unidentified seismic object, but their investigation led them to a shocking conclusion. The culprit was a 200-meter-high mega-tsunami in Greenland's Dickson Fjord. How did that happen? Imagine a landslide so massive it moved enough rock to fill 10,000 Olympic swimming pools, crashing into the fjord with enough force to launch a wave taller than Seattle's Space Needle. The resulting seiche, a sloshing of water back and forth, like a bathtub being shaken, generated vibrations that rippled through the Earth's crust for days. But here's where it gets controversial. Climate change is the root cause. The landslide was triggered by glacial thinning, a direct consequence of rising temperatures. This isn't just a geological event, it's a climate-driven catastrophe, Hicks emphasized. The study published in Science highlights how atmospheric warming destabilizes glaciers, which in turn unleash hydrospheric chaos, water sloshing, and lithospheric tremors, Earth's crust shaking. It's a chain reaction that most people overlook when thinking about climate impacts, and this is the part most people miss. The team didn't stop there. A separate study using the SWAT satellite confirmed the seiche's existence by capturing its sloshing pattern in unprecedented detail. Thomas Monahan of Oxford University, lead author of that study, called it a game changer for tracking extreme events in remote Arctic regions where traditional sensors fall short. Climate change is creating extremes we've never seen before, he warned, adding that these events are accelerating in places we can't easily monitor. So what does this mean for the future? The Greenland Mega-Tsunami isn't just a one-off anomaly. It's a warning. As glaciers melt and landslides become more frequent, could similar planetary-scale vibrations become the new normal? And if so, how prepared are we to predict or mitigate such disasters? Let's discuss in the comments. Is this the canary in the coal mine for climate-driven geohazards? Or are we still underestimating the scale of what's coming? The answers might lie in the next seismic signal we hear, or the one we don't.